All right, guys. So last section we're going to talk about, got this broken up into a couple parts, but the last section that we're going to look at is 5.10, and we're going to do this in 3 parts. And in 5.10, we're going to look at the derivatives and the integrals of something called hyperbolic functions. Okay, now that's what we're going to do next week. Before we get into hyperbolic functions, as far as derivatives and integrals, getting into the calculus side of things, we've kind of got to know what they are. So that's this first pieces. So this first little bit is looking at hyperbolic functions and actually figuring out what they are. And so hyperbolic functions are just a special type of exponential functions. Okay. Now, we do use some similar notation with hyperbolic functions as we do with our trig functions. And so you'll see that here. And if you get into more of a Calc 2 class, then you might get into a little bit more kind of the connection, some of the, we'll see some of the similarities, but then you'll also see some other similarities with them if you get into a Calc 2 or Calc 3 class probably. But we're just going to kind of get into it. So what you'll see is, first of all, we have these 2 hyperbolic functions that are kind of our basic hyperbolic functions. Hyperbolic sine and hyperbolic cosine. And as far as how we can read these, a lot of times I'll just say hyperbolic sine, hyperbolic cosine. You'll see that the notation is sine with a little h and cosine with a little h. There are some shorthand ways that you can, or abbreviations that you can say with these. I haven't heard, there's some of them that are kind of universal, but then I've heard different ways of saying different ones. So, and kind of when I've tried to find the correct way by doing searches, what I found is that there isn't one agreed upon way. You may hear hyperbolic sine referred to as synth, because it looks kind of like sine with, or synth, if you try and sound that out. Most of the time you'll hear, if you hear somebody trying to abbreviate hyperbolic cosine, they'll say cosh. But like I said, because there's not one agreed upon way that people abbreviate these, they kind of just make sounds, and whatever sounds good to them is what they use. I'm going to stick with the more formal names: hyperbolic sine, hyperbolic cosine, etc., even though it's more of a mouthful. But I've also heard with hyperbolic sine, sinh is another one I've heard. And so, like I said, I'll just probably say hyperbolic sine and hyperbolic cosine most of the time. All right. So what these are is hyperbolic sine is defined as e to the x minus e to the negative x over 2. And hyperbolic cosine is defined as e to the x plus e to the negative x over 2. And then the other 4 the other 4 hyperbolic functions are defined in similar ways as we do our trig functions. So hyperbolic tangent would be hyperbolic sine divided by hyperbolic cosine. So it would actually be the same thing as saying e to the x minus e to the negative x over e to the x plus e to the negative x. So technically it would be e to the x minus e to the negative x over 2 divided by e to the x plus e to the negative x over 2. But if you have this over 2 and this over 2, those are going to cancel out when you write them as a fraction. Hyperbolic cotangent is just the reciprocal of that. So it could be written like 1 over hyperbolic tangent, or it could be written as hyperbolic cosine over hyperbolic sine, or it could be written as what those actually equal. So e to the x plus e to the negative x over e to the x minus e to the negative x. And then hyperbolic cosecant and hyperbolic secant. Hyperbolic cosecant is the reciprocal of hyperbolic sine. So that's the same thing as just saying 2 over e to the x minus e to the negative x. And hyperbolic secant is the same as saying 2 over e to the x plus e to the negative x, because it's just the reciprocal. So again, you can see some similarities with these hyperbolic functions as with our trig functions. So you may be starting to see why we use some similar notations for them. So there is, so you guys do have a handout, or you guys have access to a handout that has these rules on them. I'm going to post them on PowerSchool in this week's stuff, so that's where you guys can get them. Oh, sorry. And so as you're looking at that, one thing you'll notice is, oh, sorry. Nope. Sorry. Gotten a little ahead of myself. One thing you'll notice on there is there's some identities, which we'll look at a couple of those in a little bit. And some of those identities, while they're not the same as our trig identities, there's a lot of similarities with them. And so we'll kind of break those down. And so again, the more we look at these, you can see, again, these are completely different functions. They have different meanings, but there's a lot of similarities in these in our trig functions, and that's why it's a similar notation. What they represent are completely different things. Again, our trig functions are talking about right triangles. These hyperbolic functions have to do with exponential functions. So they're not the same kind of functions. There's just a lot of similarities in how they're related to each other. And so, again, that's why the similar notation is used, is because of the similarities in how these functions are related to each other, in the same way as there's similarities in how your trig functions are related to each other. Okay. So, first we're just going to look at how we can evaluate these functions. And I think some calculators might have hyperbolic functions on them. I'm not sure about the TI-83 pluses. I know I've looked before. I just can't remember if they had them or not. Where you can actually just type in the hyperbolic functions of it. It's been a while since I've actually hunted for them on various types of calculators. But the reason that is because you really don't need to actually have a button in there, because we know what they mean. So we know that a hyperbolic cosine is just e to the x plus e to the negative x all over 2. So the hyperbolic cosine of 0 is just going to be e to the 0 plus e to the negative 0 all over 2. Now, in this case, I don't even need a calculator for it. Okay, that's not always going to be the case, but in this case, I don't even need a calculator. Let's not even consider needing a specific hyperbolic cosine button. I don't even need a calculator for this one, because I know e to the 0 is 1. E negative 0 is still 0, so e to the negative 0 is also 1. And 1 plus 1 is 2. 2 over 2 equals 1. Okay, now, as I said, they're not all going to be quite that easy. That we can do it without a calculator. But even with a calculator, we don't need a special button for it. We just need to know what these functions mean. So hyperbolic sine is e to the x, and in this case my x is negative 3, so it's going to be e to the negative 3 minus e to the negative x, and the negative of negative 3 is 3 over 2. Now, this one is not quite like the last one where I can do it without a calculator. I don't need a hyperbolic sine button, but I do need a calculator to be able to type in e to the negative 3 minus e to the 3 divided by 2. And you should get negative 10.01, around 3 decimal places, 8. There's a couple things let me actually go ahead. I did that on my calculator in front of me, but I'm going to go ahead and pull up my screen calculator just to make sure we talk about how we type these in, just in case we have forgotten. So when you're typing this in, since we're typing in a fraction, you have to put parentheses around the whole thing. E to the -3. You have to close the exponent parentheses, then your minus e to the 3. Close that exponent parentheses and close your numerator parentheses before you divide by 2. Okay, so if you didn't get the -10.018 the first time, it was probably with how you typed it in. All right, so then the last one, hyperbolic tangent of 1. Remember, hyperbolic tangent is just hyperbolic sine over hyperbolic cosine. So that's e to the 1 minus e to the -1 over e to the 1 plus e to the -1. And I'll type that into my calculator. Parentheses in the numerator. And since it's just e to the 1, I'm not even going to use my e to the x button. I'm just going to use my e button, because e to the first power is just e. And then I save myself a couple parentheses there. Minus e to the -1. So you have two options here. You can type it in as e to the -1. Close your parentheses. Other option, you could just type it in as 1 over e. And again, avoid having to do some extra parentheses in that regard. Either way is correct, so I'll leave it as that on the top, but then when I do my bottom, I'll do the exponent one, just so you can see the various ways of typing this in. But notice how I have parentheses around the numerator and parentheses around the denominator, and then e to the -1, close my parentheses for the exponent and my parentheses for the denominator, and I get 0.762. Next, we're going to look at some of those identities. So as I mentioned before, there's these similarities between these hyperbolic functions and the trig functions. They have similar relationships to each other, and they also have a bunch of identities that are very similar. I do want to point out that the identities don't match up exactly. So with our trig identities, we had a trig identity that said that sine squared plus cosine squared equaled 1. Okay, that identity does not work in hyperbolic. Hyperbolic sine squared plus hyperbolic cosine squared does not equal 1. However, we do have one that's kind of similar. Hyperbolic cosine squared minus hyperbolic sine squared equals 1. We're going to go ahead and verify that identity. So, thinking back to pre-calculus, I know this was your favorite section when we got to verify trig identities. We're going to do it with the same kind of process with some hyperbolic identities, because I know you guys have been missing that process just so much. Sarcasm there in case you didn't pick that up, but you'll be okay. So we're going to try and verify these identities. These two, got a bunch more on that sheet, and you'll do some on your homework and all that fun stuff. So here I'm going to look at, when we're verifying identities, we always pick a more complicated side. So I've got these two sides of the equation. I'm going to start with one side, manipulate it until I make it look like the other side. So here I'm going to, looking at this, I've got hyperbolic cosine squared minus hyperbolic sine squared on one side, and then I've got 1 on the other side. So hopefully we can see that the side where it's just 1, that's a very simple thing. So the more complicated side is going to be the left side.